So we're going to finish up our talk today about combustion reactions, about chemical transformations and balancing chemical transformations with the energy that is produced and some of the issues that are associated with energy production in the United States right now. So we have a lot of choices available to us, but some have more consequences than others. And so we're going to hopefully kind of piece together some of the ideas surrounding why maybe some energy sources may be more harmful than others to our environment. Okay, so let's take a snapshot. Let's take a look at the energy use in the U.S., and this is in exajoules, which is a huge number. And we can kind of see right off the bat that we used wood a little bit, but then now we don't really use very much wood compared to others. Coal kind of peaked, and then it's kind of stayed relatively flat. We certainly use a lot of petroleum, and we'll talk about what exactly that is. And natural gas has also been quite a bit on the rise. Nuclear represents only a small amount of our total energy input, as well as other stuff like renewables and hydroelectric. Okay, so what exactly are fossil fuels? So fossil fuels are largely hydrocarbons that we remove via excavation techniques from the ground, and each type of fossil fuel typically is used for different things, and so we can see here that as you get larger and larger, as these chains get bigger, you go from stuff like methane, which would be natural gas, to something a little bit larger, maybe like 5 to 10 atoms large. Now you go from gases to a liquid. So now this is a gas, and this is more of like gasoline or a liquid. And then as you get to really quite large things, now you're talking about waxes. Things are used in asphalt or in paraffin or in candle making. So the question might be, how do we get fossil fuels? Well, first off, we get a crude oil. So we dig up and we extract these barrels of crude oil from the ground, which are generally there from the slow decomposition of plant matter for over hundreds of millions of years. And then this crude oil is a mixture of hydrocarbons. So that's to say that it's everything. It's all from 1 carbon to 50 carbons. And so we kind of boil the whole bunch in these large kind of columns. And these large columns, ultimately the lighter material flies right up and out. And then if you're only a little bit, if you're a little bit heavier, you won't make it quite as high, and you come out as gasoline. If you're a little bit heavier, then maybe you come out as kerosene, and if you're a little bit heavier, then you're diesel. And of course, as you're heavier, your boiling point gets higher and higher until you get to the waxes down here. So we're able to actually fractionate. We're able to fraction off the different sizes due to their boiling points. Okay, so one consequence of us utilizing so much fossil fuels is this idea of the greenhouse effect, and that is that we might be inducing, or we pretty much are inducing, a climate change, in that the planet is actually getting warmer than it has in the past, and so why do we think that? Well. So the idea is pretty simple, and that is that as we release more and more and more CO2 into our atmosphere, which we know it comes from the combustion of these hydrocarbons, the CO2 in our upper atmosphere actually will trap and re-irradiate some of the sunlight that comes through. So we have this sunlight that kind of comes into our Earth, and some of it kind of bounces back off. And in fact, what happens a lot of times with CO2 is it's either reabsorbed or it bounces back off again. And so we ultimately will trap energy in our planet at a higher rate than it's leaving. And as a result, this is causing the Earth to warm up slightly. The question might be, how do we know it's CO2? Because there's of course lots of changes that are happening. it's pretty. People feel pretty good about the fact that it's CO2 from the available data, and mostly it's because we have dramatically increased the amount of CO2 in our atmosphere over the last 100 years or so. So it's for over 650,000 years, CO2 has really never been that high. Even during periods when it was very high, it's basically never been even close to as high as it is currently. And so, even though CO2 probably doesn't have any direct impact on yours, or my health, it's probably indirectly absorbing energy and increasing the temperature of the Earth. And so I'd like to finish up this particular talk by actually doing a comparison of different fuel sources for combustion reactions that we use. And so you can actually measure energies kind of head to head in a lot of different ways. One of the ways you can do is you can just look at, for instance, like a BTU, which is a British thermal unit, and this is how much energy is effectively in that fuel source. And so one of the things you can do is you can look at things like coal, natural gas, gasoline, hydrogen gas, and then in fact sugar, right? And so if you look at just the energy in these objects, you see that if we compare something like coal to natural gas, it seems that natural gas actually has an advantage over coal, and then if we jump it again from natural gas to gasoline, you can see that once again gasoline seems to have more energy in it. But perhaps a better way to compare these is to say, well, how much energy is it for every 10 grams of material? So if we have 10 grams of each of these objects, then we can look at really the energy density of these objects, because people want to know, for instance, if you want to power your car, your home, we want to see, like, in a limited quantity, how much energy can it produce. And so, when one compares coal to natural gas, you can see that natural gas has much more energy than coal does. It burns cleaner than coal. Coal tends to have a lot of other metals in it, like mercury. However, coal has the advantage that coal is easily transportable and stored. Natural gas is a gas, and it can be challenging to both purify it and to get it to its proper place, although it is getting better. It looked like originally that perhaps gasoline was a much better option than natural gas was. However, if you actually do a head-to-head comparison of just 10 grams in the material, you can see, in fact, actually natural gas is in fact better than the corresponding gasoline as well. Although, once again, gasoline has the advantage as being a liquid, it's easier to transport, certainly in trucks, than natural gas is. The clear winner, I think, amongst this whole list is actually has no carbon in it whatsoever, and that is going to be right here, and that's hydrogen. So hydrogen, when you combust hydrogen, it has no carbon in it, and so H2 plus O2, this produces water as the only byproduct. So it's pretty much the cleanest thing that we have when it comes to. I guess I should balance this, shouldn't I? Just to be good about okay. Just to it's pretty much the cleanest combustion reaction that we have available to us. And you can actually see that the energy density is incredibly high. For 10 grams of hydrogen, and although hydrogen is pretty light, you can produce a tremendous amount of energy. And so this is widely believed to be the fuel of the future, or at least hoped to be the fuel of the future. The only problem, of course, is hydrogen is challenging to transport. It is combustible, and it can be dangerous, and a lot of people don't really want to have hydrogen tanks in their cars, for instance. And so that safety concerns is something else as well that ultimately is going to have to be addressed in the future.